In modern web development, we typically also work with third-party libraries. We don't write all the code of our projects on our own. Instead, typically, we utilize third-party libraries so that we don't always have to reinvent the wheel on our own, but can add certain functionalities to our projects and then just focus on our core business logic. Now, in this module, we will have a look at third-party libraries and how you can add them to your TypeScript project. And specifically, we'll have a look at two types of libraries and what working with them in a TypeScript project means. We'll have a look at normal libraries, which you could use in regular JavaScript projects as well. And you will learn how you can use them in TypeScript and get the most out of them. But then we will also have a look at some TypeScript-specific libraries. The difference will be that these are libraries that really utilize and embrace certain TypeScript features to give you a brand new way of working with them, to give you certain functionalities you can't build like this with vanilla JavaScript. So let's have a look at both in this module. Now we'll start with a very popular utility library, Lodash. Now what you learn here basically acts as an example of any JavaScript library you want to use, no matter if that's Lodash, jQuery, or anything else. Now a little side note at this point, if you're interested in how to work with React and TypeScript, or let's say Node.js and Express and TypeScript, I have dedicated modules on that later down in the course, because there you will learn a bit more than just adding them with TypeScript. But for simpler libraries like Lodash, like jQuery, and so on, here's an approach that will work. So we want to use Lodash in our project. Lodash, of course, is a JavaScript library. We don't need TypeScript to use it. We can use it in any JavaScript project, and we can install it as you basically learn here on Lodash's official docs. If you're using npm, which we are, you can run npm I or npm install, that's just a short form, -- save Lodash. So here in this example project, which uses Webpack without a production workflow, though just a development workflow, there we can add this library by just running npm install -- save Lodash. And this will now install it into this project, and thanks to our Webpack setup, we can just import it into our code files and utilize it there. And that would be the same in any Webpack-powered JavaScript project. If you're not using Webpack, then of course you could also simply use the CDN and so on. However, what I will show you in the next steps a little bit later in this module will only work in a Webpack setup. So here we have a Webpack setup. We now installed Lodash, and now if we want to use it, we can simply import it here. We can import, let's say, _ from Lodash. That is a syntax which should be available with Lodash installed. However, this now already gives us an error. Could not find a declaration file for module Lodash. And we'll have another problem. If we want to use Lodash, for example, to shuffle an array, well, we could console log _ shuffle and then pass, let's say, a simple array to this shuffle method. The shuffle method is a method Lodash supports. We can learn this in the official documentation of Lodash. There, if you search for shuffle, you learn that you can shuffle an array with this method. So it kind of should work, but it really doesn't work this way, as you can tell. If I now start my Webpack server here, we will see that this in the end gives us an error. And again, it tells us that it can't find a declaration file for module Lodash. So this is not really working in the way it should. Now, the problem with that is that Lodash is a simple JavaScript library. It's built with vanilla JavaScript and it's built for vanilla JavaScript. We can verify this if we go to Node modules, where we have a lot of dependencies, because we have a lot of dependencies of Webpack and its dependencies there. But here, if we search for Lodash, here it is. And we expand this, we see there are a bunch of JavaScript files in there, right? And that's in the end all of Lodash's source code. Bunch of JavaScript code, but certainly no TypeScript code. Now, what's the problem with that? The problem is TypeScript doesn't understand what's in this package. It doesn't understand which methods Lodash exports. Now you will see that it actually works if we go to the tsconfig JSON file and we make sure that we do emit an output upon an error. So if we switch no emit on error to false, so that we do emit new output if something errors out. If I now start this again, it in the end will give us that same error, so we'll still see that. But if I reload this page here, you actually will get an output here. You can ignore the error at the bottom here. You will see an output which is the shuffled array. You see it looks different every time I reload. And that's very interesting. It proves that Lodash works. It proves that this code is correct, but unfortunately TypeScript does not understand it, and it can't because Lodash uses JavaScript, not TypeScript. Now, the problem is there is no TypeScript version of Lodash, so we have to live with that. And that's a scenario you will encounter quite a bit. You want to use a certain third-party library, and it's only built for JavaScript, and hence you get errors like that. This is annoying because in theory we can of course use it. TypeScript builds up on JavaScript. We can use any JavaScript library in a TypeScript project. We just have to translate it to TypeScript. And that thankfully is possible. So let me turn on this setting here, no emit on error to true. And let me show you how we can tell TypeScript about Lodash and about what it offers. You can install the so-called types of a third-party library. If you search for Lodash types, you will find an npm package which here is called @types/Lodash. There you also see an install command which will run in a second. But if you go down to details, you also find a link to a GitHub repository. It links to Definitely Typed, which is a huge repository with tons of translations for all kinds of third-party libraries. Here we are in the Lodash folder. And there you find so-called .dts files. So not just .ts, but .dts. These are so-called declaration files, which means they don't contain any actual logic, but if we have a look at the shuffle DTS file, they contain instructions to TypeScript. They basically tell TypeScript how something works and what's included in this package. And you can explore different files here, also in different subfolders, to learn more about that. So in the end, these files simply provide a translation from plain JavaScript to TypeScript. They don't contain any logic that runs, but they define the types this library works with. They define the types you use, the types you get back when you call a method, and so on. You can also write such DTS files on your own, and the official TypeScript docs provide a guide on that if that's what you're interested in. But for your own TypeScript projects, you don't have to do that, because if you're writing TypeScript code only, TypeScript of course understands that. But if you're working with a third-party library written in JavaScript without any TypeScript code or without built-in .dts files, which some third-party libraries ship, by the way, even if they are written in JavaScript, Lodash doesn't though. So if you're working with a library that does not contain built-in translation files and that is not natively written in TypeScript, then using such a types package is the solution. So here we then run npm install --save @types/Lodash. You can actually also run save dev, because that is a dependency that's really only required during development, because then the code is compiled to JavaScript anyways. And this now installs this translation for TypeScript to understand it. And you see, as soon as this is installed, this error is gone. And if I now restart npm start, you will see the error won't come back here either. So you see now this works without any errors, both in the compilation as well as in the browser. Technically it worked before as well, but now with the translation, we also can utilize TypeScript. And for example, now we also get auto-completion here in the IDE. If I type a dot here, I see the Lodash methods I can use. This, therefore, is a very important piece of knowledge, something you definitely have to be aware of, which allows you to use regular, normal, vanilla JavaScript libraries in a TypeScript project and still get great support, great auto-completion, and avoid errors with the help of these translation types packages, you could say. And these packages, which are always named @types/Lodash, types and then the package name, these basically exist for any popular third-party library you can find out there. You can always search for library name and then types, for example, jQuery types, and you should find such an entry. So that is how you can work with types and vanilla JavaScript libraries. Now, what do you do if you have a library where you can't install types, as we did it for Lodash, for example? For Lodash, thankfully, we had such a types package, and as I mentioned, for most third-party libraries you have that, but not necessarily for all. Or what if you have some other JavaScript code? Let's say in your index.html file, you have some other script code which executes there, where you set some global variable. Global. This is set. Something like this, where you in the end know this will be available globally. As you know, such variables added like this will be added to the global window object, and you want to utilize them from inside your TypeScript code. For example, here, if I want to console log global like this, I get an error here in my IDE. And if I run tsc-w to start compilation, I also get an error here. So it doesn't like that global thing, even though we know that it will work because our index.html file defines this global variable. And since we have defer on this script will be executed after this script down there ran. In such cases, you have another syntax available in TypeScript, and that is the declare command which you can use. You can declare certain variables, for example, to TypeScript. You can say declare var global and tell TypeScript that, for example, this will be a string or that this is anything. This basically tells TypeScript, don't worry, it will exist. Therefore, if we do save this, and I quit this compiler and use Webpack instead, we do see this output on our page because it technically works, and with declare var, we also tell TypeScript that this exists. Now I'm going to remove this dummy code here, but being aware of declare, of this keyword, of this command, is important. It allows you to declare TypeScript features or variables where you know that they exist, or let TypeScript know about packages, global variables in general, which TypeScript can't know, but where you as a developer know that they will be there. So we had a look at Lodash, a third-party library that's built with JavaScript for JavaScript. You also find certain third-party libraries that really embrace TypeScript and TypeScript features and give you a brand new way of writing code that works because you are working with TypeScript. One example is Class Transformer. An even better example is Class Validator. We'll have a look at both here. Now let's start with Class Transformer. Let's say in our project here, I actually have a model, a data model. Let's name it product. And I'll name it product.model.ts, but you can name this file whatever you want. My idea is that in this file, I define a class for a product. So I describe how a product should look like. For example, that it has a title, which is a string, and a price, which is a number. And then I have a constructor function where both can be initialized. So string and price, and then I set this title equal to t and this price equal to p. And of course, we could have used the shortcut initialization where we only use the constructor. Then let's say we also have a method, getInformation, where I return an array, let's say, where the first element is the title, and the second element actually is a string where I have the $sign and then injected into this string this price. So a very simple model here, a very simple class. And now we can, of course, use this class, if we want to, in app.ts. So there I will get rid of Lodash and instead import product from /product.model. Now for that, you need to make sure that in product model, you actually export this class. Otherwise, you can't import it. And here we have to export product like this because I'm using a named export here by adding the export keyword right in front of the class. So now here, of course, we can create a new product, book, which costs $12.99. And thereafter, I can console log p1 get information, and we should actually log this array. So if we now run npm start here, our Webpack dev server starts up, and we should see this nice array with information about this book. So if I reload here, here it is. Now, that's not too fancy, of course. That works, but that's nothing new. Now, a common scenario in bigger apps is that you might be downloading some data, let's say, from a server. You're fetching data from a backend server, and that server then in the end returns you some JSON data, which you parse, and which then might be a list of products. So here we might have products which we get from the server, where we then have a title, a carpet, and a price, $29.99, and where we then also have this book. So title, book, and their price of $10.99, let's say. So that's a very simple array of data, which we in the end got from the backend. Now, these are, of course, JavaScript objects, but they're not instances of our product model. And that is a typical scenario. When you get data as JSON, it has no attached data, like to which constructor function in your frontend code it belongs. Your server doesn't know that, and JSON also is a format that just transmits basic data. You don't have rich metadata to your objects attached there. Or at least you would have to do this manually. So, in other words, the products we get here are objects which don't have a getInformation method. Now, traditionally, if you now wanted to convert that into instances of your model, you would have to do that manually. You could have your loaded products, which then, let's say, uses products, calls the map method, and on every product in that array, we then return new product for prod.title and prod.price, and thereafter we would have an array full of real product constructor function instances, and then we could actually loop through that, loaded products, and then in there, for example, console log prod.getInformation. This is how we could manually transform an array or also a single no-name vanilla JavaScript object into an instance of a specific constructor function, and hence we would get this output. Now, doing this manually is cumbersome. It's a bunch of extra steps here, and this is only a simple transformation, of course. That's where the class transformer package can help us. It makes that very, very simple. There, we also define a class in TypeScript in our case here. Then we might be getting some data, let's say, from a server. And then we actually can call a simple convenience method, and it will automatically convert our data into the right models. Now for that, let's first of all run npm install class transformer -- save, like this. And once this finished, let's run npm install reflect metadata -- save, a package this package in the end depends on. So here, let's import this too. And then, as it also instructs us here in the setup instructions here, import reflect metadata in your root entry file. So in my case here in app.ts, I import this third-party library we just installed as a dependency of our library. Now, that actually were the Node.js steps, and therefore we can skip this one. In the browser, we still have to install the same packages though. And adding this import here is fine because we are using Webpack. And therefore now we actually are good to go. And now we can import something from class transformer, and that something is the plain to class method. This package also has a couple of other methods. You can learn more about them here in the official docs. But plain to class is the main method. You can use it here to set your loaded products, for example. Instead of doing this manually here, as we did before, we can set loaded products equal to plain to class, and now pass in two arguments here. The first argument is the class we want to convert it to. In my case here, product. And I don't instantiate it or call it, I just point at that class. The second argument is the data we want to transform. So in my case here, that is products. And now what this package will do is it will go over this array and transform every plain vanilla JavaScript object here in the end to an instance of this class. So if we now save this and run npm start again, the Webpack dev server boots up again, and it should build this project without errors. And if I reload the page, I get the same output as before, but of course with less code from our side, because we are using this package. And the amazing thing about this package is that it works that well here because it builds up on TypeScript. It in the end utilizes TypeScript. It utilizes the fact that we have a class there at which we can point. But to also be honest, this package works particularly well with TypeScript, but it doesn't use a TypeScript specific feature. Classes, for example, also exist in vanilla JavaScript. So whilst this is developed primarily for TypeScript, it actually also works in vanilla JavaScript. That will not be true for the next package though. So we had a look at Lodash, which is a vanilla JavaScript package where we needed to install some translations. And we had a look at Class Transformer, which is also working in vanilla JavaScript, but also works particularly well in TypeScript. Now let's have a look at Class Validator. This now is a package which really utilizes TypeScript. It builds up on the concept of TypeScript decorators, and it gives us a brand new way of working with them. Or at least almost brand new. If you followed through my decorator module in this course, you will actually see something here in this lecture, which we kind of built on our own there as well. Now, however, with this third-party library, we don't have to reinvent the wheel from scratch. We don't have to build it on our own. And this library also arguably is a bit more elaborate than our solution in the decorators module. I am talking about validation. This is a package which allows us to add validation rules with the help of some decorators inside of a class. And then whenever we instantiate such a class, we can actually validate it for the rules we set up there with the help of decorators. Now to get started, we just need to import this package here. So npm install class-validator-save, and thereafter we can start right away. So let me restart the Webpack dev server. And to use this package, we have to add a couple of decorators to the models, so to the classes, where we want to validate certain properties. So in my case here in the product model, I will import something from class validator. And now again, if you followed through the decorator module in this course, this is a concept which I already also built from scratch there without this package. But of course, we built it in a very naive and basic version. With this package, we don't have to build it on our own, and it's also more elaborate. Now, from class validator, we can import certain decorators. For example, is not empty, or also is number. We can also import is positive. Now we can add them to the properties we want to validate. So here, for example, on the title, we can add is not empty as a decorator like this. And these are all decorator factories, so you always have to execute them. And also here is number and is positive. Let's execute that. Now to use decorators here, you also should go to the tsconfig JSON file and make sure you turn experimental decorators on there. Thereafter, save this, and now these errors here should also go away. We also need to restart the dev server though, so that it picks up the new tsconfig JSON version. So now we added these rules, these validation rules here. We're basically saying that title must never be an empty string and the number should be a positive number. Now we can create a new product here, let's say there, new prod, where we call new product, and I pass an empty string for the title, and then minus 5.99 for the number. If I then console log new prod get information, and execute this, let's see whether it works. If I save that, it works. Well, we're not entirely there yet. With our decorators, we set up the rules, but these decorators on their own don't do much. Instead, we now also have to import the validate method from class validator. So from this package, we import validate. And we have to execute this on a concrete instance of the class where we added our decorators to. So in this case here, we can run validate and pass the new prod to it. And validate will then return a promise which actually might yield validation errors. So we can then add then here. If you were in an async function, you could also use async await, of course. And here we get back the errors this validate function finds. Now important, we always end up in then, even if there are errors. So if there are validation errors, we don't get into some catch block, we always go into the then block. Now in here, we can now check if errors, which is an array, dot length, is greater than 0, which means there are validation errors. In this case, we can log validation errors and maybe also output the errors we found. So console log errors, and otherwise, in my case here, I will log the information. Now, of course, it depends on the application you're building, what you want to do here. You might want to show an alert to the user in this case here if there are errors. You might want to reset the input, whatever you want to do. Here, I'll just log something to the console. And if we now save that, well, you see validation errors, and then here an array of the errors that were found. For example, the first error is on the title property that it should not be empty. And the second error is on the price property that it must be a positive number. And this is how easily you can add quite powerful validation to your projects with this decorator-based approach. Related to what we did earlier in the course in the decorators module, but as I mentioned multiple times, more elaborate with a bunch of built-in rules, and you can learn all about that, of course, in the docs of this package, and without reinventing the wheel. So the class validator package really is a powerful package you should be aware of if you're building bigger projects with TypeScript. And that is already it for this module. Now, obviously, there are tons of third-party libraries out there you could use. There also is more you can explore on the class validator and class transformer packages. But the idea here is not so much to dive into all the features of these packages. I rather leave that up to you to explore. The idea is that you get a feeling for two important things. The first thing is that with TypeScript, you can use regular JavaScript packages like Lodash without issues. You might get errors initially. Keep in mind that technically it worked though. But you can also work around these compilation errors then by importing the right types, the right translation from JavaScript to TypeScript in the end. And such translation packages exist for all major and popular and even a lot of small JavaScript libraries. You also might be working with JavaScript libraries which have these translation files, these DTS files built in already. There, of course, you don't need to install such translations thereafter. Well, and besides these vanilla JavaScript libraries, which might need translations, you also might have libraries like Class Transformer, which work fine in vanilla JavaScript, in modern vanilla JavaScript at least, where you also have classes, but which also work without any extra translations in TypeScript projects. And then we have packages like Class Validator. They really embrace TypeScript-specific features and give you a brand new way of thinking about your project and of solving certain problems. In this case here, by utilizing decorators. Knowing all these things is super important and gives you all the flexibility you need for your future projects. Now, in the last module, we learned how to work with third-party libraries in TypeScript. And that's exactly what we'll build up on in this module. We will build a tiny application, a very simple website, where we will use third-party libraries to send HTTP requests and also to render a map with the help of Google Maps. So that is what we'll do, and of course we'll do all of this with TypeScript. For this, attached you find this starting project. It's the good old starting project we already know. And there in app.ts we can write some code. In index.html, well, we got basically nothing. Now, my goal here is very simple. I want to build a simple web application where we can enter an address. Then I want to look up this address and convert it into a pair of coordinates. And we'll do this with help of Google, with one of Google's APIs. And then I want to render these coordinates. I want to show these coordinates on a map, which we will also render with help of Google Maps, or with help of Google, specifically with help of the Google Maps JavaScript SDK. So we'll be working with two third-party libraries here, this HTTP sending library and the Google Maps library. And with that, I'd say let's get started. And let's get started by building the very basic skeleton. Now, this is no HTML and no styling course, so I will keep this fairly simple. I'll create a div here in index.html, which will get an ID of map. My goal is to render the map in this div later. Now, in this div, at the moment, I'll add a paragraph where I say, please enter an address, so that we see this paragraph whilst we haven't picked a place yet. And below this div, I'll add a form without an action and without a method, because I will handle it in TypeScript. And in this form, I want to have an input of type text with an ID of address, and below that a button of type submit, where I say search place or search address, whatever you want to say. And the goal is, of course, that when we submit this form, we get the value the user entered here, and then we convert this into coordinates, which we render here on a map. Now, let's add some styling, because we need at least some basic styling. And therefore, I'll add a link here and point at app.css, which is a file we have yet to add. And in this CSS file, I'll set up some very simple styles for the map. I'll give it a width of 90% and a height of, let's say, 20 rem, so that we see something on the screen. A border of 1 pixel, solid in a light grayish look. A margin of 2 rem top and bottom, and auto left and right to center it. And then I will use display flex in there to set up flexbox, where we can use justify content center and align items center to center this paragraph, which I show initially in the middle of this box. I will also set text align to center, so that the text in the paragraph also is centered. And with that, for the form, we can also select this by the form tag. Here, I also want to use text align center to center this all in the middle of the screen, so to say. Give it a margin of 2 rem and auto, so to also have some spacing between the map and the form. And that should be it. On the page, we should now see something like this. Now, I want to change my font here. So for the overall HTML selector, I'll set the font family to sans serif. But with that, I'm good. And you can certainly style more. You can certainly style this input or the button. But I don't want to worry too much about the styling part here. Instead, I want to make sure that this works. But feel free to, of course, improve the styling here. With that prepared, however, let's make sure that now we actually fetch whatever the user entered here and looked it up with the help of Google. So in our app.ts file, we need to check for this form submission here. For this here, I will create a form constant and reach out to the form with document query selector, querying for the form tag. And since we have only one form tag in the entire document, we'll of course fetch that. So this gives us access to the form. On that form, I will add an event listener. And I'll listen for the submit event. Now this form, of course, could be null as always, but we know it won't be, so we can add this good old exclamation mark thereafter to tell TypeScript that this will not be null. And then here we have the event listener, and I will define a function which should be triggered, and that is the search address handler function, let's say. And this function should be triggered whenever this form is submitted. Now in this function, we'll get the event object, and I will first of all call event prevent default here. And also let's give TypeScript some hints here, and let's inform it that this is an event so that it knows that this prevent default command here will exist. With that, we prevent the form submission, we ensure that no request gets sent, but now I want to get access to the address the user entered. Now that shouldn't be too hard. We have one input here and it has an ID of address, so in the end we want to get the value that was entered into this input. And we can do this here by simply defining another constant, address input, which we get with document query selector, or actually get element by ID, and then the ID was address, that was the ID assigned to this element, and just as before, we know this will never be null, so we can add this exclamation mark here. And with that, we got our entered address here by accessing address input dot value. Now, why does TypeScript not like value here? Because it doesn't know that what we fetch here is an HTML input element. So let's tell TypeScript, let's convert this to an HTML input element with the typecasting here. Now TypeScript doesn't complain about that value access here anymore and gives us the entered address. And now we need to send this to Google's API. Let's do that with help of some other third-party package in the next lecture. You can search for Google Geocoding API and you will find the official Geocoding API docs. The Geocoding API is an open API which you can use to translate an address to a pair of coordinates or a pair of coordinates to an address. Now here we want to do a lookup where we provide an address, so this normal geocoding request here, and get back coordinates. Now for that we can send a request to this URL, but we need an API key to do that. And we can get one for free. All you need for that is a Google account and also a credit card. Unfortunately, you need that. It will be free because there's a very generous free tier which you can use every month, and we will not exceed that free tier with what we're doing here. But still, you need a credit card to be able to use Google Maps features, unfortunately. If you don't have such a credit card, unfortunately, you can't use the API. So create a Google account, and then to get such an API key, click on Get Started here. And Get Started will take you to a page where you can tell Google which features you want. And we want the Places feature because that includes the geocoding API, but we also want the Maps feature because that will include the Google Maps JavaScript SDK, which we need a little bit later. So check these two and then click Continue. Next, you have to select a project for which you want to enable this, and you can either create a new one or pick an existing one. Once you do that, you are forwarded, and you should be asked whether you want to set up billing for this account. Simply confirm this. And after a while of waiting and loading, you will be presented your API key, which you can use. Side note, you can also restrict the apps which are able to use that key in this Google Developer Console. But here we can just copy that key and use it in our project. So let's store that key, maybe here in a constant, Google API key. And let's next focus on sending a request. For that, let's again Google for Google Geocoding API so that we get this URL again here. This URL is the URL to which we need to send a request. And for that, we need some way of sending a request from inside our TypeScript and therefore our JavaScript code. Now, sending requests is possible without a third-party package. In modern JavaScript, in modern browsers, you have the fetch API. This is built into browsers. It's a globally available function, and you can use it to send requests to URLs. Now, there's nothing that speaks against this API, besides the fact that error handling can be a bit clunky with it, but I also want to practice the usage of third-party libraries. Therefore, we will use the very popular Axios package. This is a package you can use in JavaScript, and therefore also in TypeScript, to send HTTP requests. So we just need to install Axios to start using it. For this, in our project, where we can use npm to manage dependencies, we can run npm install --save Axios, just like this. And this will now install the Axios package. With this installed, we can now import Axios here, import Axios from Axios, and you will see something interesting. If I now start using this and I type a dot here, I get autocompletion. And for example, you have a get method here, which will send a get request to a URL. So here we actually got built-in TypeScript support. And if we go to Node Modules and we have a look at the Axios package, here it is, you will see that in there is an index.dts file. So the Axios library authors already bundled their library together with such a TypeScript translation package. In there, everything is explained to TypeScript. This package, or this file here, basically explains to TypeScript what this JavaScript library is able to do and which types it uses. Now, some libraries do that, and Axios is one of them. You can tell pretty fast if a library does this or not if you start using it. If you get no autocompletion support and you got a lot of compilation errors, you probably need to install extra types. If you get good support, like we do here, and you will get no compilation errors thereafter, well, then you already got a library with built-in type translations, and hence you don't need to install any extra types. Good to know, and here we have a great example. So since we have built-in support, we can start using Axios right away. And I want to send a HTTP request to this URL now. So let's copy this URL and let's enter it here. And I will enter it between backticks to create a template literal so that I can easily swap parts of this string for dynamic, for other values. So let's paste in that string. It is quite long. And let's start by replacing your API key at the end with our Google API key, which we stored in this constant. For this, since this is a template literal, we can add $ curly braces and then point at Google API key to use this constant. In addition, let's swap this address. Here we got a dummy address entered, and of course there I want to use the address the user entered. Now just one important note, this address of course is exactly the text the user entered, and therefore it can contain special characters, white space, commas, and much more. And not all these characters and symbols are supported in URLs. So we need to convert this entered string into a URL compatible string. And thankfully TypeScript, and JavaScript specifically, has a built-in function that helps us with that, the encode URI function. We can call that and pass a string to it, and this will convert this string to a URL compatible string. And with that we got the finished URL to which we can send a request to get back our coordinates. Now get gives us a promise because of course sending such a request is an asynchronous task. And there we have a then block if this succeeds, or catch if we have a technical error or an error response code. So here we'll console log any errors we might be getting at this point, because normally we should succeed. And therefore here I will expect my response in the then block, and I also want to log this response then. So now with that I'd say let's see what this gives us. Let's rerun npm start to bring up that Webpack process again and start building this. And let's go back to our application and enter a place here, like 6th Avenue. If I hit search address, you see after a while you get an output here. And there you should have a status code of 200, which means that the request succeeded. And you have a data field, which holds the data the server replied with. That data field has a results field, And in there we have an array, as you can tell. In that array, we got a couple of items. The number varies. And these are basically the results Google found. And the first result is typically the best one. So if we have a look at that, we see, for example, the formatted address. So the address which Google found for this address we entered. It's a bit more complete than what we entered. And we got the geometry key here. And if we expand this, we see that in turn has a location key. And this finally is an object with the coordinates we are interested in, a latitude and a longitude. So in the end, we have to drill into data, results, and then there the first result, geometry, location, and we will have an object with a latitude and longitude. And we will be able to then render this latitude and longitude on a map later. So for now, let's just extract this. And let's get our coordinates by accessing response.data.results, and then there the first result, .geometry.location. So really drilling into this. Now what you will notice, of course, is that whilst TypeScript does not complain here, we also got no good TypeScript support here, right? If I type a dot here, it's not suggesting that there is a results property. And indeed, I could try to access anything here, even something which does not exist on the response. And that makes sense. How would TypeScript know what will be in the response of any URL I'm sending a request to? TypeScript does not go ahead and send a request during development to find out what's in there. That would also not be that good. But we can tell TypeScript what we expect to be in the response, because this get method actually is a generic method. And there, this any thing here, that is actually the type of the response we expect to get. So here, I can add my response type. And I can tell TypeScript that what I expect is an object which has a results key, which then in turn is an array full of objects where every object has a geometry key, which then in turn is an object which has a location key, which then in turn is an object which has a latitude, which is a number, and a longitude, which is a number. So definitely quite a complex type. But with that, if we type a dot here, I get auto-completion, and TypeScript understands what I'm accessing here. And of course, we can also pull this type out of here and create our own type alias, maybe here. Google geocoding response. That would be my custom type here. And then I can tell TypeScript that here I expect to get that Google geocoding response. Now, of course, actually the response contains more than just the results array. It also has a status code, and it also has multiple other fields in each item of the results array than the geometry. Now, of course, you can simply add all these fields to your custom type here, but here I really just want to focus on the values I'm actively interested in. And therefore, there is actually one other field which I will add, and that is the status next to results. So right here on the top level, we got status, and that will be a string which tells us whether Google succeeded or not. And status will actually either be okay or a couple of other values. This is basically a status message Google responds with to tell us whether it succeeded fetching coordinates for this address or not. And of course, in the official docs, we can learn which kind of responses we might get back here. If you scroll down a little bit and click on understanding the response, you learn what's inside the response you get back. And there, if we click on geocoding responses, and then on status codes, we learn about the available status codes. And for example, we also got 0 results if nothing was found. We got a couple of other codes as well, but here I really only care about these two. So I tell TypeScript that here I get a status code which is one of these two values. Now again, it might have another value as well, but this is good for me here. As I said, you can of course write this in a more complete way. Now with that added, down there in the then block, we can check if response.data.status is not okay, which means something went wrong. And in that case, we can throw an error here. And therefore, we will end up in the catch block where we could set up some error handling. So here we'll throw an error, could not fetch location. And then here in the error handler, to do something, we can throw an alert where we output the error message at least. This is of course just some very basic error handling. Otherwise, if we have a success response, we fetch our coordinates here, and now we can use these coordinates to output them on a map. So how can we output the coordinates on a map now? For that, again, we'll use a Google API. If you search for Google JavaScript Maps or Google JS Maps, you'll find the official docs for the Google JavaScript Google Maps API. And here you learn how you can use Google Maps in your web application to render a map. And it's really straightforward and simple. First of all, we need to add this script here, which will add this Google Maps SDK to our application. So simply grab that script and add it to your index.html file above your script. Now important, we don't install this with npm because it's not published to npm. Hence we use this CDN link, which pulls the script directly from Google's servers. And here we need to set up our API key. Now that's of course the API key we already have here in the TypeScript file. So we can just copy that into index.html and replace your API key with it. And also get rid of this and callback equals init map thing at the end. This would trigger a function as soon as this map is loaded or as soon as this SDK is loaded, and that's not something I want here. So with that, we're loading this SDK, and now we can use it. And here's where we'll have a problem. I want to use it to render a map, and rendering a map is actually straightforward. In the official docs, we see that in the end we have to instantiate this google.maps.map constructor function, pass a center to it, which is essentially, this pair of coordinates we're getting from the backend, and a zoom level. So we can just copy this, and then here, once we got the coordinates, execute this code, and maybe store map here in a constant named map. But of course we get an error here, cannot find name Google. And that makes sense. This will be available globally, but TypeScript doesn't know that. It will be available globally because of this JavaScript SDK we're importing. But of course TypeScript doesn't know this. You learned what you can do there. You can of course use declare var Google and set this to any. And with that you're telling TypeScript, it's fine, this will exist, don't worry. We can do that and the error goes away. Now we can also use our coordinates here instead of the hard-coded ones. And if we also want to render a marker, that's also possible. In the official docs, if we click on adding a map with a marker, we learn that adding a marker is straightforward. We just use the map we created and create a marker with this command and point at this map. So I will just copy this code snippet here. And back in our code, after we created the map, I create my marker like this, and the position here again are my coordinates. So this will now render a map and place a marker on it. The only remaining thing is that we need to ensure that this map is rendered in the right place. By default, it looks for an element with an ID map, and that is what we have here. But if you chose a different ID here, make sure to adjust this in your TypeScript code. And with that, if we save this, it compiles without errors. And now if I enter an address here, it should render this. So this is working, and we can adjust the zoom level here to be zoomed in a bit more. For example, change this to 16. And now if we try this, we can see it a bit clearer. But it is working, and that is what we can tell. We can scroll around and use this map. This is all nice, but it's not optimal. Of course it works. Thanks to declare var Google, we're not getting any errors. But we're also not getting any type support. If I introduce an error, if I, for example, refer to .map instead of .maps, it compiles without issues. And it only crashes in production thereafter if I try to render a map. Now I get an error here, caught by our error handler. So this is of course not what we want. We want type support. We want to handle dumb mistakes like this during development and not at runtime. So how can we ensure that TypeScript knows Google Maps? Types to the rescue. If you search for types Google Maps, you find various packages which add types for, Google Maps. Now we didn't install the Google Maps package through npm, but we can still install types for that package through npm. And here I'll go for this first package and simply install that into our project. So let's go back, quit the development server, and run npm install --save-dev add types / Google Maps, one word. That was the name of this package. This will now install global types for this package. So now if I restart this with npm start, let's see if we have a better situation. If I remove this declare var thing here, or I comment it out, it still compiles. Now this Google Maps thing here is detected. And if I try to access .map here, I get an error. I also get auto-completion now, and it sees, yes, there is a maps thing. It also tells me that this map constructor needs a div or an element where it should render the map as a first argument, and then some options for the map. So this is now working here as it should. And this is of course a great step forward, because now we have our working application, and it did work before as well, but now it works also with types and with a proper type support. And this therefore is another great practice for how you build applications with TypeScript and use certain TypeScript features, but it's especially a great practice for how you can work with third-party libraries. Some, like Axios, bring their own types, others aren't even installed with npm, and yet you can add types with an appropriate types package. I hope this module was helpful for understanding this, and therefore also for all future projects you might be working on, where you most likely will also work with certain third-party libraries.